Let's start our session with messaging essentials. There is a typical problem that messaging solutions are trying to solve. Imagine two applications with a need to send data to each other. There are many reasons for that. You can think of bank transfers, invoicing, some booking information, order processing, delivery details, insurance, or anything like that. They could be located in the same data center, in different data centers or cloud, but still have a need to exchange the information. It's a simple task. All you need to do is to send data from application 1 to application 2. You can do it in a synchronous way, meaning application 1 can do a call, so it will try and connect to application 2, saying, "I have some data for you and I will sit here waiting until you will receive it." Which is fine if everything works. But what happens if it doesn't? What if it is going to fail? We are talking here about sending a business-critical data. It doesn't matter if you transfer $1, $100, or $1 million. You simply do not want it to fail. Also, until the transfer is completed, application 1 keeping this spot open, which basically means it is locked and will stay busy for some time. There is a better way of solving this problem. Let's take those two applications, but instead of connecting directly, application 1 will send the data to another service, which will take care of delivering it to application 2. We call this messaging. You're essentially removing direct communication layer between apps and creating indirect connections. Think of isolating and buffering, which is great for reliability, but also great for overall solution scalability. I mean, think of what will happen in our initial example if first application suddenly will start sending a lots and lots of data while application 2 is not ready to receive it. What will happen? While in the second example, those will be just placed in our service, a message queue. And the second application will take them one by one, working on its maximum rate without going down. So, messaging as a synchronous way of connecting applications, because you are holding messages in a queue, is an excellent way of solving that problem. Now let's get back to our application sample. Did I mention where those applications are running? They could run in the same place, for example, in one data center, or different ones. However, imagine that you are not using MQ. At this point, it matters where those applications are. You need to know the network, location. You may be already moved part of your workload to the public cloud or planning to move it to a private one. So when you're not using MQ, which is supposed to create isolation layer between applications and their network, you would need to keep updating each application anytime you have those changes. Where those are deployed, what is the network route, latency, and all of that. By adding MQ here, you're simply allowing an app to ask, "Where is my MQ today?" Underneath technology will always help to find the right path to queue, disregard where those applications are located. So there is no real problem of running in a cloud, data center, containers. If you have MQ, we have it covered for you. MQ is perfect for flexible, reliable hybrid deployment. So what if you want to run MQ in the cloud? As soon as you start discussion with scalability and flexibility in mind, it will lead to containers. One of the main buzzwords here is Docker, and another word that you will hear a lot is Kubernetes, which essentially is the management layer for Docker containers. Running MQ in containers is supported for several years now. We basically have a pre-installed image of the product, which is extremely useful in repeatable deployment scenarios. For example, when you need to scale and do not want to think about installation, initial configuration, and management. So those containers can be running anywhere you want, whether it will be public cloud like IBM Cloud, AWS or Azure, private cloud like IBM Cloud Private, or anywhere in your data center, as containers are very, very flexible. What if you need even more simplicity and flexibility? Well, there is something that we used to call a managed service. As an example, you can take a look at MQ on IBM Cloud offering, where IBM has taken MQ, put it into a container, and put that one on IBM Cloud. And even further, as IBM now allows you to deploy an MQ that is managed by IBM onto AWS. Now you can configure your MQ instance, but IBM will do a deployment and management of that container for you, dealing with the tasks like infrastructure and version maintenance. So think of it as MQ service in the cloud. By the time you will get yourself a cup of tea, you can get MQ instance running in the cloud and ready for your enterprise load. At this point, we will close our microlearning session. If you are seeking more information about MQ deployments in the cloud, follow the link in the description. Please subscribe to the channel, give us your feedback and ideas. Thanks for watching.